The title of this presentation is Sustainable Yield Exploration for a Commercially and Recreationally Important Northern Fish Species, Lake Trout, Sylvanus namakush, through Data Limited Modeling. It's an overview of a recent Northwest Territories Cumulative Impact Monitoring Program initiative, and the resource presented here is part of joint efforts of myself, HChymyGeosciSympPres, and my colleagues. In general, this presentation will cover primarily two aspects of our current research. The first being a review of the fishery history, including site description, harvest history, and current concerns. The second of this aspect of this presentation will introduce data-limited models, why they are important for this fishery, current methods being explored, where data for this fishery is being collected from, and analysis methods. I will end off with some information regarding the significance of this project. In the first section of this presentation, we'll look at a site description and history into Great Slave Lake commercial fishery with an emphasis on lake trout. So a little bit about the water body. Great Slave Lake. It is a member of a chain of freshwater lakes known as the Northern Great Lakes, located between 50 and 60 degrees north. Specifically, Great Slave lies in the Mackenzie District of Northwest Territories and is the 5th largest lake in North America, 10th in the world. Due to historic Pleistocene glaciation, lakes of the area are relatively young ecosystems with limited known anthropogenic effects, although changes have begun to be noticed. Areas surrounding these lakes are generally underdeveloped with low populations. However, there have been some industry development in the areas around Great Slave, mainly mining and damming. The lake lies at a contact zone between two different types of geological underlay, which has resulted in two unique areas with very different characteristics. Those being the east arm with a Precambrian shield underlay, and the western portion, main basin, with alluvial plain underlay. This section of the lake also contains much less variation in the underwater topography and a much shallower average depth than the eastern arm. Characteristically different rivers enter the lake from the different zones, which has helped aid in the physiographical differences between the two areas and has been a large influence for the fish community. Multiple fishery levels take place on Great Slave Lake, largely reliant on lake tourists. So prior to 1945, only a domestic fishery occurred. On July 29, 1945, the commercial fishery began. But during 1944 to 1947, the lake was also under biological investigations with the goal to better understand the productivity of the lake to adequately manage the incoming commercial fishery. In the summer of 1948, an all-weather road was constructed, this being the Mackenzie Highway, that connected the city of Hay River with a network of Alberta roadways and increased the involvement in commercial fisheries from more companies. Knowing this and the fact that the original quota had not yet been reached and that commercial exploration was only taking place over a small area of the lake, it was determined by Rawson's first investigations that if effort were distributed more evenly over lake, accomplished by dividing the lake into administrative areas with associated limits, the entire lake pooled quota could be doubled. So this map here helps to show the subdivisions that occurred following 1948, the year that the quota had changed, and of the road completion. A commercial catch high was seen in 1949, shortly after the change in quota that increased it from approximately 1.9 million kilograms to 4 million kilograms round weight for the two primarily commercial species, those being whitefish and lake trout. 5 marketable species were involved in the fishery at this time, but only lake trout and whitefish are restricted by quota. After the observed catch high and change in 1949, commercial catch values fell far below the estimated quota. However, in 1956, Kennedy reported that no obvious changes could be detected for mortality and growth rates for lake trout, both of which may indicate a stock becoming deplete. Therefore, it was suggested that the ongoing commercial fishery of Great Slave Lake has not and will not likely deplete the primary commercial important species. Following this, in 1963, the second lake division occurred, which divided Area 1 into Area 1 West and Area 1 East. In 1972, some other important conclusions were made by Kelly. He concluded that, in fact, lake trout catch per unit effort, known as CPUE, was found to decrease for all the areas investigated in his report. He also concluded that the initial high catches were likely witnessed due to temporary effects, and therefore the decision to double the limit was based off of a non-equilibrium value, but rather effects of the long accumulated available stock. and it was therefore suggested that the pooled quota be removed to better manage lake trout. Following these conclusions, commercial catch monitoring, along with some additional biological sampling, continued on Great Slave Lake. And shortly after 1972, additional important conclusions were presented by the Great Slave Lake Working Party. Conclusions from the research published in the early 70s were mainly found from Bond and Turnbull 1973 and Bond 1974. It was presented in these that, in addition to the commercial fishery growth, demand for sport is likely to increase. CPUE has in fact decreased since the catch high in 1949. It was also concluded that lake trout are unable to withstand the extensive commercial gill netting and have become nearly absent in the western areas of the lake. Unlike whitefish, whom have responded to the pressure with an increase in growth rate and a decreased age of maturity, lake trout have not. In 1971, the quota and administration areas were revised, although still a pooled quota for whitefish and lake trout, but in addition to Area 6, with a lake trout subquota, which, after is hit, commercial fishing in the area must stop. In 1972, the lowest catches were seen thus far for lake trout, decreased by 40% from 1971 values. Following this, Bond in 1974 suggested that lake trout are so low, reestablishment is unlikely without lake closure, and Area 6, East End, should be reserved for sport and managed for lake trout. Other than small closures or changes to some small areas of the lake, administration area boundaries stayed the same until November of 1974, when in November 1974, Area 6 was closed to commercial fishery operations, following the advice of the Working Party. Currently, this area is still closed to commercial fisheries. This image helps show how recent years catches were mainly from areas 1 east and 1 west, while previous high catches came from the majority from Area 5. This helps reveal how areas have produced unequally since the beginning of the fishery. Moving on to some current concerns with Great Slave Lake trout. Ensuring sustainability of commercial fisheries is challenging. This has been made clear by records of this fishery alone. Lake trout specifically are challenging due to some life history facts, that being late maturity, low fecundity, and that they are a long-lived species. Limited data makes evaluating sustainability difficult, and harvesters have indicated a preference for whitefish over lake trout, this being a market price incentive. Aggregation of lake trout in Area 1 East during late summer and spawning season parallels with fishing pressure, and the optimal plan should aim to minimize lake trout bycatch while enabling the capture of whitefish. Currently, the need for estimating lake trout limit reference points for all areas of the lake has been identified. Moving on to look at the assessment methods. So we are going to explore why data-limited models are appropriate for this fishery by giving some background into stock assessment as well as the models under consideration. So, traditional data-rich methods. When a fishery has a large, reliable library of available information, so for example, age and size class data, stock-specific demographic population traits can be determined, these being mortality rate, growth rate, etc. And advanced mathematical models can be utilized to evaluate status and help estimate valuable management stock reference points to help ensure effective management. So what is a reference point? Generally speaking, a reference point is an estimated value used to relay important information to policymakers. They can represent goals, known as target reference points, like MSY, maximum sustainable yield, or B over BMSY, biomass at maximum sustainable yield, or limits, known as limit reference points, like an overfishing limit. What is stock status? So what is stock status? Stock status is the estimated current state of the fishery in relation to a reference point. So for example, if the harvesting level is above the overfishing limit, then the current stock status of the fishery is being overfished. When reference points are known or have been estimated with certainty, then the fishery can be deemed data rich. And ideally, management and policymakers prefer these stocks to make decisions. However, in much smaller scale fisheries, data accumulation has been slower, and this could be because of many reasons, including the fishery may be located in a remote location, may draw in less monetary value than other large-scale fisheries, thus preventing complex stock assessment, and the fishery is deemed data limited. However, the need for assessment of these fisheries still remains, with increasing pressure on sustainable food sources and reasons like some of these fisheries still contain important endemic species or have potential for valuable employment or high economic value and even recreational purposes. Therefore, to assess these fisheries, you must find the best method that utilizes the limited available information. Often, this information can include commercial catch data, commercial effort data, angling harvest estimates, and biological data. However, this could also be lacking in extent and relevance. So currently, many methods are being developed that try to incorporate data limited fishery information for reference point estimation. And examples of these include length-based methods, which require length survey information as a primary input, as well as age-based, and catch-only models, which primarily rely on a time series of harvest data. And often these models also still require additional inputs that are related to demographic population rates. So age of maturity, growth rate, length of maturity. But specifically, these catch-based surplus production models utilize a time series of catch data to estimate valuable stock reference points, and they reduce model complexity and data requirements by incorporating growth, mortality, and reproductive success into an overall production model. And they estimate MSY through a relationship identifiable between catch and biomass. Now I will introduce how we've begun to accumulate data, the models under current investigation for the proposed research, software that will be used for modeling, as well as some other important research considerations. So, available information. Through an extensive literature review, available fishery data has been located and summarized, and at present it appears we have the following available for Great Slave Lake trout fishery. First, I will define fishery independent versus fishery dependent data. Fishery independent meaning it was collected in the absence of the commercial or sport fishery operations, which then means that fishery dependent happens in relation to one of these fisheries. So moving forward to discuss some of this fishery independent data for Great Slave Lake, which includes some historical data available from the Rawson and Kennedy studies and include some aging and some sex ratio information. However, given that the original trout aging study occurred in 1947, and was done through scale analysis, literature suggests that due to the high chance of procedural errors associated with scale aging and that oathlet aging has been identified as a more accurate method for aging lake trout, it prevents us from using this oldest available aging survey data for this fishery for current estimation of reference points. There has been some post-2000 sampling done in the lake, however, with little relevance to stock assessment. So for example, Zimmerman et al. 2009 and 2006 did some genetic marker work by taking photographs of fish, and a couple of the low studies were primarily targeted on Area 6 and were angling harvest studies. The most recent fishery independent data comes from recent biological surveys that have taken place on the main basin between 2010 and 2018, which is part of a multi-species survey using multi-mesh nets, as well as on the east arm from 2012 to 2016, and primarily in Area 1 East in the main basin, we've started fall sampling from 2017 and ongoing. And in these sampling, commercial and multi-mesh nets are used. Common measurements taken in these studies include aging in some years, states of maturity, as well as length and weight data. So looking at some of our fishery-dependent data then. In 2010, 2014, and 2016, fish plant subsampling was occurring. In 2019 to present, we have the contributions from the cumulative impact monitoring initiatives, including commercial fish sampling and analysis, and currently age analysis is being done on 2019 and 2020 samples. Common measures for this sampling include fork length, weight, age by oathlets, sex maturity, and pedunity. For our catch data, we do have early years commercial catch values in multiple publications, those being Kennedy 1956, Sinclair et al. 1967, and Keller 1972. Recently, we have information from the freshwater fisheries market data from about the 1980s to present. They have represented good catches by area. So to summarize, for this fishery, we have the most reliable and standardized catch totals are available from the freshwater fisheries market data, as well as we do have some available survey data, which can be used for estimating current population-specific demographic traits used for model inputs. With this limited information, it is clear that data-limited models are appropriate for this fishery, and currently 2 of these are expected to produce reference point estimates for this fishery. Those 2 being depletion-based stock reduction analysis also known as DBSRA, introduced by Dick and McCall, 2011, and CMSY by Frost et al., 2017, which is a modified version of HChymyGeosciSympPres, which was from a 2013 publication. So DBSRA. As I mentioned, it was first introduced by Dick and McCall, and it is a catch-based modeling method for determining maximum sustainable yields and other reference points. This approach uses predetermined input distributions of population demographic traits to run simulations that draw in a Monte Carlo fashion from the known input distributions and generates possible sets of parameters. Parameters are accepted if they correspond with the assumed relative stock biomass, which is also estimated through investigations into catch highs and expert knowledge on the stock. Parameter sets that lead biomass trajectories to presumed unsustainable levels are removed, and frequency distributions of accepted sets, so parameter estimates that do not allow the stock to crash over time, are produced. From these, management reference points can be determined. Moving on to CMSY. Minimal input requirements are needed for this method in terms of demographic population traits, which makes it a solid option for data-limited stocks. From a time series of catches and an estimate of species resilience, which is defined as a population or a system's ability to reestablish to a former state after a disturbance. This model also requires input distribution ranges for some specific demographic traits, those being the intrinsic rate of population increase, known as R, and then estimated unexploited population size, known as K. Pairs for R and K are drawn in a Monte Carlo fashion and considered in final analysis if the biomass trajectories from said pair are within accordance of observed catches. The most probable pair is then decided from a set of rules. A pair is considered viable as long as a negative biomass is not projected over the time series, and projected results are consistent with input estimates for the relative biomass range, so the K range. Reference points can then be determined from simple equations. Data analysis. Data manipulations and calculations of demographic rates will be carried out in the programming language R, primarily using the package tidyverse. The evaluation of models will be done through the package DLM tool. However, there are limits with this, so ideally individual packages and or code from the supplementary material from original model publications and or other published literature that uses the models will be utilized. The selection of the choice model for the fishery. To do this, we will identify a fully assessed lake trout stock. Using simulation modeling and inputs from this fishery, we will evaluate the selected models. By comparing the data-limited model reference points to those of the data-rich assessments, we will determine the data-limited model that estimates points for the data-rich fishery most similar to those from the data-rich stock assessment. Ultimately, this model will be selected as the choice model for the Great Save Lake trout fishery. Now I'll just point out some of the end goals for this research and significance of the project. So the ultimate goal, to estimate stock-specific reference points that can be utilized by management for the continued sustainability of the Great Save Lake trout fishery, and hopefully potentially help identify areas that may need further investigations to help ensure effective sustainable management. The significance of the research. The need for this research has been identified multiple times in the available literature, as well as most recently in the CIMP for Northwest Territories. Other significance is given its remoteness and difficulties associated with research of this area. Pressure on these resources is unavoidable given growing populations and climate change adding pressure to the trout fishery. High community value is associated with the lake, given the numerous sport fishery lodges that operate on the lake and the communities. Literature suggests that research of this type is useful in data-limited situations for stock assessment as a first step in stock evaluation, as well as useful building blocks, both for comparison and for data accumulation until more aggressive methods can be utilized. At this point, I'd just like to acknowledge a couple of organizations and individuals who have contributed to this ongoing project. Thank you all. Without the help of these groups, this work would not be possible. This concludes the presentation, and thank you for listening.